The MJO returns. What's that mean? I'm Mark Sponsler, and welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, November 12th.
Stormsurf, waves, weather, buoys, altimetry, snow, temperatures, El Nino, weather analysis, essential data for outdoor people, all the time, no hype.
Be sure and like and subscribe. Ring the bell. You get automatic notifications when the videos are posted, typically on Sunday evenings. And if you'd like to make a small contribution, you can use the special thanks button down below, the heart with the $sign in it. With that, I'd like to thank the folks that donated last week. The Meal Master, thank you so much. W. Chase, thank you. And of course, Elliot Harris. We really appreciate your contributions. And with that, let's get to work. We'll start by looking at significant wave heights for the North Pacific Ocean. We see a small area of 19-foot seas. This is the beginnings of a new gale starting to develop in the northern Gulf. That'll fall south. Then we see something up in the Bering Sea, but that's all shadowed by the Aleutian Islands here, and no support for gale development. Otherwise, a fairly calm pattern is in play. But first, let's take a look at current conditions. We'll start in Northern California. We're looking at the buoys. The Point Reyes buoy, number 029. We're looking at all the energy that's hitting that buoy. From all the way up at 33.3 second period, super long period energy. We see a little bit, a tenth of a foot there. We see a big peak at about 14 seconds, something like that, and then a bunch of wind swell, and this chart goes the whole way down to 5-second period. That's just unrideable chop there. But that 14-second period certainly gets our attention. The pure swell, primary swell, 7.8 feet at 14.3 seconds from 309 degrees. Theoretically, that's producing surf that's 11.1 feet high, and it certainly was not small today, not over the top big, but definitely in the double overhead range at some top spots, and pretty solid. And you can see the trend here. We had a pulse of swell. It was at Friday evening, Saturday, things settled down, and then here was another pulse today, and you could tell it being in the water. It started out, like 2 feet overhead, and by 10 or 11 o'clock, there were double overhead sets, or maybe even bigger, and it was a bit of a scramble. So there certainly is swell in Northern California, and that's working its way down Southern California, but probably a little bit from too steep an angle. But let's go take a look anyway. So we'll go way down south off San Diego, buoy 191, the Point Loma South buoy. We're looking at all the energy there. Not a whole lot happening here. A little bump at about 12 or 13 seconds. You put all that together, we have primary swell 2 feet at 12.3 seconds from 275 degrees. That makes surf at about thigh high or something like that, and there's some secondary swell mixed in there, maybe bits of the new swell starting to show 1 foot at 15.6 seconds, but that direction is not right. That's probably wrap around from the islands or something. Then we go over to the north shore of Oahu, Waimea Bay buoy, number 106. Again, looking at all the energy, you see a nice little bump here at about 14, 15 seconds. I think that's the same swell that's hitting California. We're going to take a look at where that swell originated from. This is sideband energy working its way into the Hawaiian Islands with some wind swell mixed in. Put it all together, 2.8 feet, 14.8 seconds from 310 degrees. So that'd be surf at about chest high or so, but I'm sure there were sets in the head high range, and then some wind swell mixed in. That's that northeast trade wind swell, 3.8 feet at 8.9 seconds. If anything, just sort of putting a cross lump on it. All right, so let's go take a look back in time. We're going to Thursday morning, the 9th of November. A little gale developed here. Here's the Aleutian Islands, Japan there, California there, Hawaii right down there. A little gale developed, producing 24-foot seas. So we got deeper into the day. Seas, see that little plus sign there? It tells you the highest seas over the entire domain, 27.9 feet. Winds were 50 knots in that area, just a tiny little area, but some of that fetch looks like it could have weaseled its way down into Hawaii. Whoops. And then as we got into later Thursday night, seas went up, it says 30 feet, but more like 29 feet probably. Then the gale moved off into the Gulf on Friday. It was seas in the 27, 26 foot range and fading from there. You can actually see the front of the swell pushing south on Saturday, and then as of about Sunday morning, making its way into Northern California, and oops, that was it. That's the last run of the Hindcast. But bound for Southern California, only most exposed spots. The swell angle up north here is like 308 degrees, so it's probably going to be 310 or 311 down into Southern California. So choose your spots wisely, but there might be some surf. So what's coming for the future? So we're going to start by looking at jet stream level winds. These winds up about 30,000 feet help support the formation of gales. When those gales form, help direct their track. We're looking for a trough, a dip in the jet to the south, just like right there. Now notice, here's Japan off here. The jet pushes off Japan, splits before it even gets to the dateline, which is here. Most energy tracking up into the Bering Sea, then falling hard south. You get this dip, you get a counterclockwise circulation aloft and also at the ocean surface. That is low pressure, and of course low pressure, if it's strong enough, generates winds. Winds, if they're strong enough, get traction on the ocean surface, eventually generating seas, and those seas, as they move away from the fetch area, the shorter period energy gets filtered out, and then a ground swell theoretically gets exposed, and when that swell hits your beach, of course, you get surf. So we have the potential for a gale here up in the northeastern Gulf of Alaska, but notice this split pattern. One would not really want to see that during an El Nino year. Okay, theoretically, El Nino feeds energy into the jet, and the jet should be consolidated, but instead it's split. When it's split, it kind of does this thing where it pushes way up north. And so this is actually not a great El Nino-ish looking pattern. Anyway, as we get into Monday, the trough falls down the U.S. West Coast, kind of almost gets pinched off, still supporting gale development, or at least low pressure development, and hanging off of California as we get into Tuesday, maybe being a little bit, this is really looking like a backdoor trough, if anything, as we get into Wednesday night and Thursday, the 16th of November, almost cut off from the main flow, and then another trough, notice this, on Friday starts digging out over the dateline. This looks much better, at least initially, with, look at that, what's that, 140, 150, almost 160 knot winds feeding into it, maybe supporting gale development somewhere northwest of Hawaii as we get into Saturday. Then the trough gets pinched off. The trough off of California moves onshore, probably making for a rain event. And then notice a ridge building just off the coast of California. That would support high pressure. Literally, you see the clockwise flow here in the upper atmosphere, and that would manifest itself down at the surface as well. And there we are, a week out. So potential for gale development, but nothing like super El Nino-ish looking. Let's go take a look at surface level pressure, surface level winds. We see the beginnings of our gale. It's really just a low pressure system. You need to have 35 knot winds. We only have 30 knot winds as of right now, but that's supposed to build. There you go. There's your 35 knot winds. That'd be later tonight into Monday morning off the California coast. What's that? Maybe one. Oh, that's almost, what is that, 20 degrees? So that'd be about 1,000 miles off the coast of San Francisco. And notice the winds sort of pushing almost northeast at Hawaii, and not any fetch really aimed at California. So if anything, this gale will be a swell producer for the Hawaiian Islands. And look at that. In fact, we'll go back right there. Look at that. Full northeast winds at 40 knots aimed right at the Hawaiian Islands. So some swell theoretically from that. The low circulating off the coast. You want it to move onshore to start producing moisture into California, but it just can't. The jet just won't push it in. It just lingers off the coast. Look at that, generating south winds. We're into Friday already. Then it finally limps onshore as we get into Saturday. But then we know there's another trough building somewhere out here on the dateline. And sure enough, by Saturday, there's your 40-knot north winds aimed right at Hawaii. Unfortunately, like almost impacting the islands. So probably not the best scenario. And then you get a week out, 180 hours out. There's 50-knot winds. That'd be a storm aimed right at the Hawaiian Islands, but with what looks to be northwest winds. So probably kind of a mess. Hopefully this will lift north. Also notice tropical system. Let's go back just a little bit here. You can see it. In fact, I think if you go back, it's just starting to show on the charts, maybe in a day or two. That building, the hope would be that it too gets caught up by the jet, recurves, and makes it across the North Pacific, perhaps tapping jet stream energy, going extratropical. That is what happens typically during El Nino type years. We'll see whether that happens, though. It's a week out. The models are not very good at all on getting any of this correct more than about 5 days out. All right, let's go look at the effects of those winds on the ocean surface. We know of a little gale there in the Northeast Gulf. It falls south, starting to produce 24-foot seas over a tiny area as we get into Monday, and then 26, almost 27-foot seas early Tuesday to 28, almost 29 feet. Now aimed more due south here, but I think some sideband energy should be good for Hawaii. But notice the fetch off the California coast. It looks like it's just all, in fact, oh, look at that. It falls almost southwest. Not much, but just a little bit. So Hawaii certainly should see something from it. California, who knows? I'm not really counting on much. Maybe small waist high kind of surf thing, but most of this is focused somewhere in the channel between California and Hawaii. Anyway, that fades out as we get into Thursday. We're looking for hopes, some sign of anything else. There's this little tiny thing forecast for the Gulf, but I'm not even going to call that a swell producer. And then this system starts building the gale north of Hawaii. So we get into Saturday night, Sunday morning, the 19th, with seas in the 20, 22, 24, 26-foot range. Yeah, 26 feet. And then up to 33 feet aimed at the Hawaiian Islands. The last frame of the model, 180 hours out. We'll see where all this goes, but it has been on the charts now for 3 or 4 days. So I'd say the odds of it happening, of something happening, are pretty good. The exact details to be determined. And then, of course, the tropical system off of the Philippines. Local wind forecast. Here's our developing low. High pressure behind it. Notice that making a gradient, sort of making those northwest winds, at least at the moment. Trades have been strong over the Hawaiian Islands. Look like that's going to continue, if anything, building stronger as we get into Monday, with a building south wind regime, not particularly strong, but later on Monday. In fact, even this evening, there were south winds up in Northern California. Not strong, 5 knots, but just enough to kind of put a wrinkle on things, and suspect that's the beginning of a much broader trend setting up. By Monday afternoon, we're into 10-plus knot winds along all from Point Conception northward. Southern California protected. Strong trades for the Hawaiian Islands. As we get into Tuesday, south winds 20 knots along the San Francisco area, maybe a little bit less down south. Strong trades for the Hawaiian Islands, making for wind swell, I guess, if that's meaningful. 20 knot south winds as we get into Wednesday along the California coast, if not stronger, to 25 knots. Trades breaking up a little bit for Hawaii. Thursday, you still. Now, notice North California, north of San Francisco, it's entirely possible you could have offshore winds there, or southeast winds, but you get into this south wind regime for Southern California as well. Trades for the Hawaiian Islands. Friday, pretty much broken record. Same thing for California, but the trades certainly lighten up for Hawaii. Your little bit of gale, notice that up here in the Gulf. As we get into Saturday, the low just basically starts dissipating. Still south winds, light winds for the Hawaiian Islands. Sunday, a light northwest wind regime for California, and then here comes the wind machine for Hawaii with the gale very close to the coast. And continuing as we get into early Monday, northwest winds and high pressure start building along the California coast. So kind of a mixed bag, a bit of weather that we're going to have to contend with. In fact, let's go look at potential for precipitation along the California coast. The blue is precipitation. The white and yellows embedded in there is snow or potential for snow, but looks like mainly rain. The first little piece of this developing low pushing into Cape Mendocino on Monday, but not really doing anything. Plenty of water, but it's all right off the coast, just spinning. Maybe we get a little blast of it along the coast from, we'll say, Santa Cruz northward, but not even really getting into the Sierra. as we're into Tuesday, and then it rotates right away from the coast as we're into until Wednesday evening. Then rain starts in earnest, it appears, for the coast of California, with pieces of it making it into the mountains. So Wednesday evening, you notice it still does this back off thing on Thursday. It's off the coast, trying to push its way into Friday, but weakening all the while. And then finally, Saturday, it moves onshore, the remnants of it, with a little bit of snow. That's probably like the Mammoth area there, only the highest elevation. This looks like a very warm core system. And by Sunday, things dry out. Next system queues up north of Hawaii, but of no interest for California, with high pressure building in control. In fact, looking at the snow forecast dashboard for Mammoth, you see, what is this, maybe 2 inches of snow on the 17th, night of the 17th into the early part of the 18th, and that's about it. Snow levels, this is the base of Mammoth. This is the summit of Mammoth. Red would be liquid precipitation. Gray would be like sleet. So you see snow starting, or the freeze level, I guess I should say, starting about somewhere off the base, maybe mid-mountain, something like that, until you get into where the actual precipitation starts on the snow starts on the 17th. The freeze level goes below the base. That's good, but then right after that, boom, temperature's really warming up there. And then we play the same game, but this is sort of more of a hiker's forecast. This is the intersection of the Pacific Crest Trail and Tioga Pass Road. Elevation right there is at 8,700 feet. You can see the freeze line, this red line. So it's just barely, coming down to freezing in the evenings, warming up to maybe 40 degrees. And then, so that's Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, the coldest right in there in Saturday. Then after that, a big warm up with temperatures 45, maybe even pushing 50 degrees in the, I wouldn't call it the high Sierra, but the lower elevations of the Sierra. All right, so the surf spot forecast. This is for Ocean Beach, goes out a week. Basically, calculated wave sizes here. So Sunday, 9 foot. Yeah, it was actually 10 or 11 at times. As we get into Monday, swell slowly fading down. Surf heights in the 8-foot range, going down to something less than that. Tuesday, smaller still. Wednesday, smaller still. Thursday, wondering if some of this isn't beginning to be south wind swell and just sort of all takes over. And then maybe a little bit of swell as we get into Sunday of next week. Let's look at the actual swell heights, 7 feet or 6.9 feet at 13 seconds. Let's go for Monday morning. Yeah, 6 at 14, something like that. Tuesday morning, 4.5 at 13. Wednesday morning, 4 at 12 or something like that, and then it looks like the south wind swell just takes over until we get into maybe Sunday, a week out, and then we start getting this 3 to almost 4 feet at 15, 14 seconds sort of thing. We do the same look at San Diego. Now, remember, everything's all shadowed here. That doesn't mean there won't be swell, but you got to know where to go, and we're not telling you where to go. You got to figure that out for yourself. The people that know, they know where to be, and they will be there, and I am not spoiling their private breaks for anything, because I wouldn't want someone to do that to my breaks either. All right, but anyway, you see rather small surf, 1.5 foot, going up to maybe 2 foot, but I guess by Wednesday, some of that's probably wind swell sort of thing. And continuing on, let's go look at the details. 1.3 feet at 14 seconds. I think there'll be bigger surf than that for sure at exposed breaks, but you got to know where to go. And that continuing the whole way through Wednesday. Then here comes your wind swell, 2.5 feet at 8, 9 seconds sort of thing. And then probably beyond a week from tomorrow, there should be some ground swell perhaps filtering in if the models are correct. Then the North Shore of Oahu, swell starting, or surf starting to fade out from that sideband energy from the gale that made the surf currently hitting California. Pretty much a small wind pattern. Notice the wind speeds trades 25, 27 knots sort of thing. That's hard winds. And then we get into, where are we on Friday? Surf picks up, But also notice here come these like southerly winds at 25 knots sort of thing. Surf goes down. Let's go look at the actual swell 3 feet at 13 seconds for Monday, and then fade out. Tiny little swell after that. Yeah, 1 foot at 13 or 14 seconds sort of thing. And then what do we have? Some swell starting to show from the gale north of the islands, 5 feet at 13 seconds sort of thing, then fading as we get into the weekend. So surf for Hawaii, surf for California, gotta know where to go, and gotta find some protection from the wind once the south winds start in California and once the trades start nuking for the islands. And with that, let's go now and take a look at the long-term outlook. What's going on with the Madden-Julian Oscillation and the El Nino Southern Oscillation? These two weather oscillations are the main impact or drivers of swell in winter months and, to a certain extent, summer months in the Pacific Ocean. So we start by looking for signs of the active phase of the MJO, the Madden-Julian Oscillation. It is this periodic weather oscillation that traverses the planet, moving from west to east on the equator. The active phase on one side of the planet, inactive on the other. They rotate west to east around the planet. The active phase acts like a low-pressure system. It is the good phase of the MJO. The inactive phase, the bad phase. It's a high-pressure system. Now, when the active phase starts moving over the West Pacific, because it's a low-pressure system, it takes warm, moist air that's down at the ocean surface, starts lifting it aloft, feeding it into the jet stream. That feeds more energy to the jet stream. That makes for a stronger jet. Stronger jet digs out troughs. Troughs make storms, and storms make surf. All right, so that's one of the good things. The other thing it does is also dampens trade winds over the West Pacific. And when that happens, that allows warm water that's normally pulled up in the far West Pacific to start sloshing east in what's known as a Kelvin wave. It's a ball of warm water. It travels under the equator. If you get what they call a westerly wind burst, maybe a couple of weeks of dampened trades, which are called westerly anomalies, and trades typically blow from the east. But when you get the active phase of the MJO, if it's strong enough, it actually can create westerly winds, especially during El Ninos. And those westerly winds take that warm water, create the Kelvin wave. Takes about 3 to 4 months for the Kelvin wave to push its way across the Pacific. It eventually slams into Ecuador, creates a warm water slick there. If you get successive active phases of the MJO, and so you get the active phase pushing across the Pacific, takes about 4 to 6 weeks, then you go to the inactive phase. And like the next month, another 4 to 6 weeks of the active phase. And so as of now, we've had 6. Well, we're in the process of the 7th Kelvin wave being generated. So piles of warm water is piled up off of Ecuador. That, of course, starts changing the upper, because you get a lot of evaporation that's not normally present over off of Ecuador. That then starts changing the jet stream, and that's how you get El Nino. All right, so we're very interested in the active phase of the MJO, 1, for producing surf, and 2, for producing El Nino, which also produces surf and precipitation if it's strong enough in the southwestern states. If you didn't watch the video last week and you live in the southwest tier states and you're interested in how much rainfall you're going to get this winter, at least the mechanics of how all this goes with El Nino is described in that video about maybe 17 or 18 minutes into the video. So go look at last week's video if you missed it. All right, so we're going to start by looking at data from the TAO buoy array, a series of buoys strung across the equator used for monitoring El Nino. This is the East Pacific here. This is the West Pacific here. This is the equator. This is the date line right here. That's New Guinea there. We're just looking at the arrows. The arrows tell you the strength and direction of the winds. So easterly winds over the East Pacific, that's trades. Pretty strong over the Central Pacific. But look at this. In the West, full-on westerly anomalies. Not even westerly anomalies, westerly winds blowing solidly. Kelvin wave being generated, we suspect. Active phase of the MJO in control. Now, typically during El Nino, at least this El Nino, as we've been even from July, the MJO has been non-existent. And all of a sudden, as we get into this, we're going to see that the MJO has all of a sudden woken up. And we'll talk about that a little bit more. But I think that's actually a good thing, because that will really start forcing the wind pattern and the warm water pattern we need to really get El Nino going. Anyway, all right, but it's not the average wind speeds. These are 5-day average winds. It's the anomalies, difference from normal for this time of year. You see, yeah, the trades are blowing pretty strong. Right here, there's a little bit of easterly anomalies are blowing a little bit too strong right in this area, but then pretty much neutral here over the western East Pacific. Over the Central Pacific, neutral. And look at this, strong westerly in the West Pacific, the Kelvin wave generation area, the area from as far west in the Pacific as you can go, across the dateline to about 170 west. 5 degrees north and south of the equator. If you get westerly anomalies and they're strong enough and they last long enough in this area, you're going to get a Kelvin wave. And I think that's exactly what we're going to get, and that is good news. 850 millibar zonal wind anomalies for the past 5 days, just to sort of get a sense of what's going on. Central or South America there, Central America there, New Guinea there, equator right there, dateline right there. The orange and reds are westerly anomalies right smack in the middle of the Kelvin wave generation area, and pretty strong and pretty much almost covering the entire Pacific other than this little tiny area right there off of Ecuador. That was on November 6th. If anything, getting stronger on the 7th, solid on the 8th, solid on the 9th, solid on the 10th, but with this building pattern of easterly anomalies here. So if anything, this looks like the active phase of the MJO in the West Pacific, maybe the inactive phase exiting the Pacific over Ecuador. Next up, outgoing long-wave radiation forecast. Just fancy word for cloud cover. If you have less outgoing long-wave radiation, that means sunlight bouncing off the ocean surface. Well, if you don't have a lot of it, then that infers that there's clouds present. So the blues, negative anomalies, mean clouds. And let's get oriented. South America, Central America, Hawaii, New Guinea there, Australia, equator right there, dateline right there, Kelvin wave generation area right in there. So more clouds than normal in the West Pacific, suggesting the active phase of the MJO. Because remember, active phase is like a low-pressure system. Low pressure takes warm, moist air, lifts it aloft, creates clouds. The statistical model says active phase of the MJO continuing on day 5 of the model run and 10, but moving more towards the dateline as the inactive phase starts following in behind it. And then on day 15, about 2 weeks from now, active phase still over the dateline region, but inactive phase starting to move into the picture. The dynamic model suggests some flavor of the same thing, just maybe not quite as strong. This is the GEFS model. It's just an ensemble version of the standard GFS model, which we use a lot on this channel. And then one more model. This is a sort of like an outgoing long-wave radiation forecast. Potential for precipitation. The green's favorable for precipitation. One would assume the active phase of the MJO. The oranges and reds, inactive phase, dry air. Well, this model and the other model have been completely asleep for months now, all of a sudden suggesting strong active phase in control, making its way across the Kelvin wave. Let's get oriented. South America, Central America, New Guinea there, equator there, dateline right there, Kelvin wave generation there. And we have, each panel goes for 5 days. There's 8 different panels here. So you see active phase making its way across the Pacific into about the end of November. Then the inactive phase shows up the beginning of December, which is probably not so favorable for surf production. So December kind of gets chucked out until you get to right around Christmas time, and then here comes the active phase. So but this would suggest a bunch of surf for the next couple of weeks, then things go silent for a couple of weeks, then things wake up again. Certainly smells like the MJO is waking up. Phase diagrams, these are the drill downs of what's actually going on with the MJO. This is the statistic model here, dynamic model here. The models had consistently been showing, and how do you read this? Sorry. MJO moves from west to east, from the Indian Ocean to the Maritime Continent, to the West Pacific, to the East Pacific, under the United States. It moves on the equator, remember that. Over the Atlantic, over Africa, then back to the Indian Ocean. For weeks and weeks, And you can see it here. The MJ active phase was like all just hanging here somewhere over Africa, and then boom, out of nowhere. And the models didn't even really, I mean, this is really the classic case of how good are the models. They don't even have a clue what's going on. They had no idea the MJO was going to wake up. And all of a sudden this week, I mean, you sort of saw hints of it, but you couldn't believe it. Now it's just, boom, here it is, welcome, and we're back in business. All right, active phase of the MJO over the West Pacific, that's where the heavy dot is. If the dot is on or inside of the circle, it's considered very weak, but the statistical model says it's going to build each one of these dots as a day and then start moving out of the West Pacific to the East Pacific, almost to the Atlantic, 2 weeks from now. Dynamic model, pretty much saying the same thing. So we've got this window of a week or two here where the Pacific will be doing some interesting things. We didn't show this before, but we're showing it now. This is 850 millibar zonal wind anomalies just for the next 2 weeks. All right. The reds and oranges are westerly anomalies, the blue easterly anomalies. And let's get ourselves oriented here. So this is the east-west anomaly pattern for the entire planet. Dateline runs right up the middle, so we know where the dateline is. The far west Pacific starts about 125 east, so right about there on the equator. And the Kelvin wave generation area ends right about here. All right, so we see right here, we had a westerly wind burst in October, maybe attributable to the active phase of the MJO. By the end of October, it was over. We had a little break for a week maybe, and now we're in the midst of a very strong, I mean, the strongest westerly wind burst we've had in months, I'd say. We're right in the middle of it now. That's a really good thing. We still have another, well, that's 5 days, maybe a week worth of that to go on. And then the inactive phase sets up. And you can literally see the active phase moving east, south of California, at least according to this model, over the next week or so. This should be feeding energy to the jet stream, should feed storm development, and certainly should help feed energy into El Nino. Now, here is another model. This is the CFS model, showing you the exact same thing, but it goes at the forecast down here at the bottom, goes out a month instead of 2 weeks. All right. This also overlays the MJO, the black line there. The dotted means inactive phase, the solid contour, the active phase of the MJO. So you can see this sort of pattern even back in dateline right here. Far West Pacific right about there. Kelvin wave generation area from there over to about here. So going in the past, you see this westerly anomalies in September, a little bit stronger as we get in the beginning of October. Another batch in mid-October. Then we had this inactive phase where things kind of didn't do a lot. We got some westerly anomalies, though, here building in the West Pacific. But now, here we are, massive westerly wind bursts, strong westerly anomalies, active phase of the MJO, 1-2 weeks making its way across the Pacific to a point even south of California. I mean, there might be a big window right somewhere around in here as the active phase passes south of California for liquid precipitation or snow. So that would be 2 weeks from now. We'll see. Who knows? But then inactive phase takes over around starting the beginning of Thanksgiving and going into December sometime. We'll see if that materializes. Now, also notice this. Massive easterly anomalies setting up over the Indian Ocean. They've peaked as of about right now. What does that mean? Well, what this really talks about, we've talked about this before, the Walker circulation. And I'm not going to get into all the details, but basically this looks like a downward branch of air hitting right about somewhere 120 east, which is the maritime continent. So it blasts down, hits the surface and splits. Some of the air moving across the Indian Ocean into the west, those would be easterly winds, with strong westerly winds pushing into the Pacific. So this is classic El Nino sort of thing. And then you have that coupled with the MJO. And the other thing is there were some thoughts that This is called it's actually called the positive Indian Ocean dipole. I'm not going to get into that. But with that starting to fade, the thought is, at least some people are saying, well, maybe that will allow the MJO to sort of wake up and become more active and then sort of constructively integrate with the El Nino base state and feed that. That's typically what you see as you get these active pulses of the MJO, and they're not particularly strong, but as they hit the low pressure bias, the El Nino indicator, and we'll get into that near the date line, they produce these massive westerly wind bursts, and then you just piles of energy crammed or shoved up into the jet stream. The jet stream starts raging, the storm machine sets off, and that's what you really associate with strong, solid El Nino events in January, February, and March, is the MJO, the active phase, is fueling these westerly wind bursts and storm cycle events in the Pacific. So we'll see if that's where we're headed or not. Hard to tell this early in the game. Then we're looking at one other thing, the outgoing long-wave radiation cloud cover pattern. Okay, West Pacific here, East Pacific. Well, actually, this is the whole planet, so the date line running right here. And that's really what we want to look at. And then over here is the maritime continent. So back last year this time, the blues, that's heavy cloud cover. It would be the upward branch of the Walker circulation all over the maritime continent. Remember, we were in La Nina. The downward branch of the Walker circulation over the date line, dry air, no surf, no nothing, things not so good. But then as we got into the summer, as we got into April and May, notice that dry air pattern just evaporated, and the wet air pattern, or the cloud cover over the maritime continent, started evaporating. Now look where we are a year later. The dry air that was here is now over the maritime continent. The wet air that was here is now over the date line and getting progressively stronger and stronger. This is classic, again, sort of El Nino setup. We expect that the MJO active phases will only feed this as we get deeper into winter. And so this is all looking exactly the way we would want to see it for an El Nino as we get into winter months. So here's the forecast for what we were just looking at, outgoing long wave radiation. But the past is down here, the forecast is up here, the date line is right here. You just see the blues are increasing cloud cover. We know that's happening. We've got actual data. We just saw it on that previous chart. The forecast is for that to just continue building and building as we get into February. And then we also see the dry air continuing over the maritime continent. Classic El Nino sort of setup. All right, now let's go look at 850 millibar zonal wind anomalies. The same sort of thing, but down at the surface. Here are your easterly anomalies over the maritime continent. The forecast again up here. Westerly anomalies, they've been steadily building. Here's our current westerly wind burst. You see, well, it's supposed to move off to the east, and then another big one forecast somewhere in December, probably associated with an active phase of the MJO, and then maybe some more out here. But also notice easterly anomalies as we get into later January, starting to move their way, at least according to this model, into the far west Pacific. Now, I don't know if I'm going to believe this or not, because this model has been teasing us, playing all sorts of games with this. I don't know that I believe any of it. It didn't even show this strong westerly wind burst that was literally happening like 5 days ago. Didn't even show it. Like it didn't know what was going on. So I'm going to take all this with a grain of salt. But let's overlay the MJO just for fun. Now look at this. It says that the inactive phase of the MJO is currently over the Pacific. We know that not to be true. The other model we just looked at, the red solid contour, is the active phase. So this model is a bit confused. Don't know what to believe. They say another inactive phase in November, active phase in December, whatever. I don't believe it. Let's go look at the low pass filter here. So this is your high pressure, low pressure bias. Now this has been spot on. Very generalized, but this solid black contour, this is a low pressure bias. This was all over the maritime continent a year ago. See, this only goes back to July. But forecast, or actually it's forming now. A fourth contour is already over the dateline region, forecast holding for the next couple of months at least. This is the El Nino signature with the high pressure bias over the maritime continent. It makes perfect sense. Dry air there, easterly anomalies, not a great thing for if you live in, Australia or something like that. Pretty dry indeed, with all the moisture now setting up over the Pacific, favoring storm development in the Pacific Ocean. Exactly what us Pacific surfers want to see. Right, so what's going on down in the ocean? We've talked about Kelvin waves. Can we see Kelvin waves, or at least to have some data to give us a sense of what's going on? And the good news is, yes, we can. Data from the TAO buoy array, the series of buoys strung across the equator used for monitoring El Nino. These little X's are sensors on the anchor lines of those buoys. They grab temperature data down into the ocean, and then you use a model to fill in the gaps. 30 degrees centigrade, this is really warm temperatures here. So this was hanging back right about 169 last week. Now it's to about 167. So a little bit of eastward motion, suggesting maybe a Kelvin wave moving that way. 29 degree isotherm, this was over at 158. It's moved a degree or two off to the east. The 28 degree isotherm was back at 145. It's made good progress to the east. And the 24 degree isotherm solid the whole way across the Pacific, suggesting there's a good amount of warm water already over here in the East Pacific, and it looks like more is headed our way, courtesy of the Kelvin wave that is in development right now, courtesy of the active phase of the MJO and the westerly wind burst currently occurring. Now, this is just at mean average temperatures. Let's look at the actual anomalies. Difference from normal for this time of year. Massive area of 4 to 5 degree temperatures from, where is that? 140 west, so that's out almost south of Hawaii, the whole way into Ecuador. And then here we go, 3 to almost 4 degree anomalies setting up at 155 west, due south of Hawaii. The next Kelvin wave number 7, moving this direction. And this is not being generated by those westerly anomalies that are occurring now. This was from the previous westerly wind burst, a month ago. We suspect the current westerly wind burst is going to create yet another Kelvin wave. Maybe not distinct, but it's just going to take more warm water and pump it into this pool and just continue this stream of warm water moving off to the east. This is exactly what we want to see. This is great news. Here's data from another source, and I'll show you in a minute, satellite data, but you can't read temperatures down in the ocean from a satellite. But what you can infer is temperature differences down in the ocean by the height of the ocean surface. If you have warm water at depth, it expands. It'll create a bump it'll displace water above it up and create a bump on the ocean surface. If you have cold water at depth, it contracts and create a little divot on the ocean surface. So this data suggests basically what we were looking at before. Same picture. Lots of warm water off of Ecuador. New Kelvin wave here building south of Hawaii. And then a whole stream of warm water flowing off the maritime continent at depth, likely being driven by this new westerly wind burst that's over in this area, blowing hard right now. Again, this is a great picture, exactly what you want to see. And here's the source data for that, the sea level anomalies, the height of the ocean. So Chile here, Peru there, Ecuador there, there's the Galapagos, Central America, Hawaii up here, that's the date line, that's the equator there. See these positive anomalies, 0 to 5 to 10 centimeters above normal. This all says the height of the ocean, and it's just 5 degrees north and south of the equator. That's what really matters. Says there's piles of warm water from, well, there's the date line. We're even... Well, there's New Guinea, almost just a bit halfway between New Guinea and the date line. From there, the whole way into Ecuador. That's months and months of warm water stored in reserve, and with more westerly anomalies here, only going to feed this warm pool more. Again, great news. So then we go look at sea surface temperature anomalies. So those Kelvin waves, they and that warm water, it's all pushing to the east. So it hits here, Ecuador, erupts to the surface. The trade winds capture or take that warm water and start dragging it back across the surface. So it's a cycle. Warm water traveling under the equator west to east. It erupts to the surface off of Ecuador and then starts flowing back along the surface towards the West Pacific. And you get this giant warm pool, as you can see here. Now, not as warm as it was last week. There used to be some pretty intense bouts of or pockets of warming here. But remember, we saw those easterly anomalies off of Ecuador. So they've that creates some upwelling, kind of mixes things up so you get more of a generic view. But I think that will be a short-lived event, and all of a sudden you'll see the warm signature waking up here. But we're also seeing is pretty good warming almost the whole way out here to the date line. The Nino 3.4 region. These are regions used for monitoring sea surface temperatures. Nino 1, 2 right here off of Ecuador. Nino 3 is like somewhere here. Nino 4 is out here. But the official El Nino monitoring region, it's sort of a hybrid of the Nino 3 and 4 region, starts, well, California's right there at 120 south on the equator, just 5 degrees north and south of the equator, out to 170 west. So you can just, or you can put them both together and put it out here. And you see lots of warm water there. What's that do? Well, normally the temperatures are really cold over here. They're like these blues off of Peru and Ecuador, driven by trades, but that's all shut down now. So you get a lot of evaporative water or air, or evaporative water creating moist air lifting up into the atmosphere. That changes the whole jet stream pattern, and that sort of starts sucking the jet stream towards it in winter months down over California and through the Gulf of Alaska and over the dateline, whereas last year we didn't have that. Now, yes, we had a lot of rain, but that was different. The 2 years before that, it was all pure El Nino. Last year was a transitory state. El Nino was already building. That's how we got all this warm water here. And it continues to build like almost a year later. So this is a great El Nino sign. Sea surface temperature trend for the past 7 days. So I'm talking about that little pocket of easterly anomalies right off of Ecuador. Well, there it is. You can see the blues. That's falling sea surface temperatures driven by easterly anomalies, driven by the inactive phase of the MJO that's exiting the Pacific off to the east. The active phase of the MJO and westerly anomalies are building here. Now notice they're not warming sea surface temperatures here. What they're doing is they're taking warm surface water that's here, pushing it underneath the equator in the form of a Kelvin wave that's going to make this whole trip, going to take 4 months to make it across the Pacific. Here is sea surface temperature anomalies, again, just backed off. You can also see warm temperatures here in the maritime continent. If you get westerly anomalies pushing over here, they're going to drag warmer than normal water right over here into the Pacific, get you your Kelvin wave. And then here is the classic El Nino warm triangle right there. Actual temperatures in the Nino 1.2 region is the area right up there along Ecuador and Peru. You can see them sort of trending down a little bit there. Plus 1.696 thousandths of a degree above normal. Neutral is there. So warm temperatures in the Nino 1.2 region, but not as warm as they were back in August. They were up to 3 degrees above normal. And then we go to the Nino 3.4 index. Pretty solid indeed. Now this is about 0.2 of a degree below what it is. It's still plus 1.270 degrees above normal. So here's neutral. El Nino starts at 0.5 degree above normal. So that'd be a weak El Nino. A moderate is at 1 degree, okay, and above to 1.5 degrees. So this says we're in moderate territory, but this is off by about 0.2 of a degree. So really read this as about almost 1.5 degrees, okay, and 1.5 degrees up to 2 degrees is strong El Nino, and 2 degrees and above is super El Nino. So we're like right on the cusp of a strong El Nino. In fact, let's look at one other bit of data. Here is sea surface temperatures and anomalies. Here's your dates here, current date right there. This is the Nino 1.2 region. You can see we were up at 3.5 degrees for 1 week there in July. We're down to 2.2 degrees today. Nino 3 here, Nino 4 here. Here's the official El Nino monitoring region, the 3.4 region. We started So we were at 1 degree above normal, so that would be, what's that? Half degree to 1 degree. So this would be moderate, in moderate range. 1.5 degrees was moving into strong range. Now, officially, it's 3 consecutive months in a row, okay, and this is only 1 week, so it's not really a trend, but it gives you an idea. 1.5, 1.6, 1.7, we dropped a little, but now we're back up. The last reading was 1.8 degrees above normal. That's in strong El Nino territory. If you're 1.5 and above, you're in strong El Nino. So we theoretically have been there since August 23rd. That's what, a month and a little bit more. By the time you officially do the 3 overlapping 3-month periods, it's like El Nino is already gone by then. But you see where the trend is, you see where it's going, and we're heading in the right direction. This chart here shows you the expansion of those warm anomalies. This is the East Pacific here, this is the West Pacific here. This is December of last year. Warm water in the West Pacific, cold water, the La Nina signal in the East Pacific, but then Kelvin waves pushing across. You see the buildup of warm water as we get into June, July, August, September, October. Here we are right now, the continued building of warm waters. And we want to get this to 170 west. We want to see, so what is this? 1, 2, 3, 4. 1, 2, 3, 4. So strong El Nino would be this guy, this shade of orange right here connecting the whole way into this. We are so close to having that happen. Probably a couple weeks, maybe a month at most. By the end of December, we should probably be in strong El Nino territory. I don't think we're going to get to super El Nino, but strong El Nino buildup is progressing, it appears. So here's another way of looking at this upper ocean heat anomaly. So this is as much the Kelvin wave monitoring. The previous chart was just surface. But you can see back a year ago, warm water in the West Pacific, cold water in the East Pacific, typical La Nina sort of setup. We get into February, or actually December, first Kelvin wave number 1. January, Kelvin wave number 2. March, Kelvin wave number 3, moving from west the whole way across the Pacific. Kelvin wave number 4 in April, each of these driven by the active phase of the MJO. Kelvin wave number 5 in May. Then we had a little bit of a stall here in July, but then as we got into August, another Kelvin wave. Number 6, Kelvin wave number 7 right here in flight. We have another westerly wind burst occurring right now. Kelvin wave number 8, or at least 7 and 8 are probably all going to team up to be one big massive Kelvin wave pushing across the Pacific. Again, classic El Nino sort of build-up pattern, exactly what you want to see. All right, so here's the current sea surface temperature anomaly projection. I'll drag this down here so you can see the date right there. Okay, we're just going to give you a little historical perspective. So this is this year's El Nino. Now here is the 2015 El Nino from the exact same time. You notice a bit of warm up here, a little bit warmer out this way, and maybe we can go back and forth. That one, there's a current. Here is the new one, or the 2015 one, which turned out to be super El Nino. So we're not, we had pretty good warming here, but we still don't have the warming out here that we had in 2015 at this time. So, and this was super El Nino. I don't think we're going to get to super El Nino. Now let's go look at a super El Nino. Here is the 97 El Nino, just solid dark red filling the entire, just a massive area. We're not going to get there. We're going nowhere close to this. So, but the flip side is 97 was like, it was a pretty stormy mess up in Northern California for a good part of the winter. So maybe there is some good from having a strong El Nino, but not a super El Nino. But you decide for yourself what you think is best. And then finally, what does the atmosphere think is going on? Well, we look at a thing called the Southern Oscillation Index, the difference in pressure between Darwin, Australia, and Tahiti. Tahiti in the Pacific, Darwin over in the maritime continent. If pressure is lower in Tahiti, which is what you'd want to see during the active phase of the MJO and or El Nino, the index goes negative. So here's Tahiti's value, here's Darwin's value. This is pressure in millibars, okay? The daily value, minus 27.55. All right, that's a good sign. And look, 1, 2, 3, 4, 5, 6, 7. We've been solidly negative for a week now. Now, we went through a period here, when was it, late October, where we were just kind of floundering for about 2 weeks. But it looks like the active phase of the MJO is having the desired effect. In fact, you can see that in the 30-day average. This is a rolling average. We're at minus 8.75. Where were we? Well, we were at minus 10, but then we kind of stalled. So that would say active phase of the MJO, then we went into the inactive phase somewhere here in the middle, and now the active phase is firing up and the numbers are dropping. Okay, we want to see this down around minus 25 somewhere at the peak of El Nino, but I think we're still 2 or 3 months off from that. The 90-day average is your El Nino La Nina indicator. You want to see it at minus 15 to get you in truly El Nino territory. We're not there. We're going back here looking. We've not been minus 15, but this is going to continue to fall as well. So, in fact, let's go look at a graph of this data. Here's a 30-day moving SOI all graphed out. Neutral, 0 right in the middle. Back in January 2021, we were all in positive territory, La Nina territory. Downward spikes are the inactive or the active phase of the MJO. The upward spikes are the active phase. When you're in La Nina, the inactive phase is more prevalent and stronger than the active phase. But then in January of this year, boom, we fell off a cliff. We went into a stall somewhere in July, but now we're starting to trend downward. I think the trend will continue downward from here forward. This 30-day moving average, I want to see it down at minus 25. We might not only get to 20 in a strong El Nino, but either way, and sort of hang there for a while. We're moving in the right direction. Sea surface temperature anomaly predictions from the CFS version 2 model for the Nino 3.4 region, the official El Nino monitoring region. So where are I? We're approaching the middle of November, which would put us right about here. This says temperatures about 1.7 degrees above normal, probably hovering somewhere in there, spiking up to maybe 1.85 degrees for a little bit in January. And if you sort of did a 3-month average, probably somewhere about 1.75 degrees is my guess, according to this. And then after that, though, you don't really want to look at this as we get into July. This suggests temperatures rapidly crashing and cooling right back to La Nina. Don't want to be there. Now that is the unadjusted. Here is the PDF corrected forecast, pretty much saying some version of the same thing. Temperatures, it's down a little bit, 1.7 degrees. I'm going to be very interested to see the updated consensus model. I think it comes out on the 21st, and what's today? We still have another, probably, so not next week's video, but the week after that. We'll see what all the models, there's like 35 different models that all monitor El Nino. We'll see where they go, but this model, not even this one up here, has tended to be on the low side amongst the dynamic models. So I'm very interested to see what all the models are going to be saying and what the consolidated forecast will be as we get closer to what should be the start of the real meat of El Nino as we get into, let's say, the Christmas time frame. All right, for right now, hey, we have surf in Northern California. Hawaii's had little consistent surf. Another gale forecast, not even a week out, 5 days out north of Hawaii, and that's probably going to throw some surf our way as well. Active phase of the MJO in control, feeding El Nino's development, pushing energy into the jet stream, but the jet stream's kind of split, and it really doesn't look like an El Nino pattern at the moment. But again, we've had this big stall, and El Nino has had a bit of a struggle getting its footing and getting traction in the atmosphere as much as we'd want to see that. The atmosphere is coupled, though. Okay, the Walker circulation is changing, and with that happening, that outgoing long-wave radiation all setting up over the dateline and building stronger, I think it's only a matter of a couple of weeks or a month before the jet stream really wakes up and starts doing its thing. Probably remember, this El Nino is not like other El Ninos that peak in like the December timeframe. The character of this El Nino is, it's a bit delayed, it's slow in getting its act together, but it has piles of momentum. It has not died, and it's been showing a very strong signal consistently in the ocean temperatures since, I don't know, since last year even, with the start of those MJOs and all the weather and everything. So the thought is this El Nino will not be denied. We're just going to have to be patient. But I think as we get into January, February, and even March, there's going to be a very interesting series of storms and events and swells and all that sort of stuff going on. So we just need to be patient. But all the signs right now are pointing towards a building strong El Nino with precipitation into California and across the southern tier states, even into Texas and southeastern U.S. Also, we have surf, and I expect that will continue and get more consistent and sort of get a heartbeat going here. Consistent swell after swell. You should be able to be getting in shape, at least north of Point Conception here. Hawaii's had a lot of consistent surf. Northern California is starting to get in that swing too. I think all of us are going to get our opportunity here if we just wait a little bit longer. All right, that's the video for this week. If you enjoyed it, give us a thumbs up. If you have comments or questions, write them up. We'll try to respond as quickly as possible. If you'd like to make a special donation, you can use the special thanks button down below. And with that, go surfing, get some waves, have some fun, and get ready. I think things are coming. All right, that's it. We'll see you again next week. Same time, same channel. Thanks for watching.